Okay, so lesson 2.7. Did we ever say it? These equations all have fractions. We can work with fractions as one option. The other option is to get rid of fractions. And that's going to be my focus today. How can I get rid of that fraction in example 1? Y multiplied by x. Okay, there's a denominator of x. How do you get rid of a denominator of x? You multiply by x. If I multiply that fraction by x, I'm not multiplying just it by x, I'm multiplying everything by x on both sides of the equation. So what we do to one piece, we have to do to the other piece. On the left, this x needs to distribute. So x times x is x squared plus, what's x times 3 over x? 3, because the x's will cancel. X on top cancels with x on bottom. Okay, so we said that was 3. There we go. On the right, 4 times x is 4x. Okay, we got rid of the fraction. We got rid of that distraction. What's my technique to solving this? Okay, set the equation equal to 0 and see what happens. So how am I going to set it equal to 0? Subtract 4x over to the other side. When I subtract 4x, how should I write that left side out? X squared minus 4x plus 3. That is our standard form there. How do you want to solve that? We could. She said quadratic formula. But before I use quadratic formula, I'm going to check and see if it factors. And if it factors, I'm going to factor. Not on this one. Hey, now, in all honesty, teaching point here, can you do the quadratic formula on this problem? Yes. Okay. If you don't see the factoring, you can do quadratic formula. You will be A-okay. Okay. So, x squared is x and x. What multiplies to be 3 and adds to be negative 4? Minus 1 minus 3. What do I do with each of those pieces? Set them equal to 0. X minus 1 equals 0. X minus 3 equals 0. What do we get when we solve? 1 and 3. Okay. Notice one thing that we have to pay attention to today. And anytime you deal with fractions, you have to pay attention to this. It talks about extraneous solutions today. Do you remember what extraneous solutions are? Okay. They appear to be good solutions, but then when you check them, they don't work. These are prime example type problems where we get extraneous solutions. So, with that in mind, what's one way to check this? Plug the numbers back in, yes? And I'm going to call that an algebraic check. I'll talk about another way on the next one. If I check this algebraically, as he said, plugging the numbers back in. So that means if we put in 1 plus 3 over 1, does that equal 4? Well, yeah, 1 plus 3 equals 4. That checks. If I plug in 3 plus 3 over 3, does that equal 4? Yeah, 3 plus 1 equals 4. I just wrote that check out. Do you have to write that check out? Okay. I'm not going to require you guys to write that check out. I never do. Okay. One of the big pieces today to be watched for, the key as to when they most likely will not work, I say most likely because there's always exceptions, but when the denominator does not equal 0, or let me rephrase that. When something makes the denominator equal to 0, that's when a solution will not work. Most of the rest of your solutions, if not all, should work. It's just when they make the denominator equal to 0. So are we okay with 1? Okay, let's check 2. X plus 1 over x minus 4 equals 0. What is step 1? Okay, get rid of the denominator would be in your best interest. How do I get rid of that denominator of x minus 4? We want to get rid of the denominator of x minus 4. We're going to multiply by x minus 4. That means the first thing we're doing is we're going to be multiplying x minus 4 times x. For my line 1, I'm just going to write it as x times x minus 4. But what am I going to have to do if you haven't done already? Distribute. Okay, plus, what happens when you multiply x minus 4 times 1 over x minus 4? The x minus 4 on top and bottom cancel, and I'm left with 1. On the right, what's 0 times x minus 4? 0. On the left, I can go back and distribute. X squared minus 4x plus 1 equals 0. And, sorry, I'm laughing at Mason's face back there. Do we have an option this time? No, this one does not factor. It is required quadratic formula. Okay, so quadratic formula, x equals negative b. So that becomes positive 4 plus or minus the square root negative b squared. Negative 4 squared minus 4ac. So minus 4 times 1 times 1 all over 2a. So 2 times 1. Clean it up. 4 plus or minus. What do we have happening under the radical? Yeah. It becomes 16 minus 4, and 16 minus 4 is 12. So that is the square root of 12 all over 2. What do we know about the square root of 12? Yeah. Does 12 have a perfect square in it? Yeah. So this could actually become 4 plus or minus. If you pull, it's 12 is 4 times 3. Take that 4 out, so it's 2 radical 3 all over 2. What can happen here? This denominator of 2 divides into both terms, doesn't it? So then I'd become 2 plus or minus, and those 2's cancel, so 2 plus or minus radical 3. Depends on the situation as to what kind of answers. I'm fine with that. Could you give decimal answers if you needed to? Yeah, you can. Now, take us back to the question of checking. What are options for checking this? Okay. Okay. So algebraically, we could plug this back in, yes? And then as you look at that, you're thinking, 2 plus or minus square root of 3, not fun. So at that point, I want to talk about how to graphically check. And we kind of looked at that in the homework. How do we graphically check our solutions? Yeah. Plug in my equation equal to 0. So y equals x plus 1 over x minus 4. And what are we going to be looking for on this graph? We're going to be looking for our x-intercepts. So if I plug in x plus 1 over x minus 4, zoom 6. Now in this case, what would it be helpful to know about 2 plus or minus radical 3? Would it be helpful to know their decimals? It would be. So options here, you could check your zeros, yes, like second calc 0. You could check your zeros, so there's, and notice I have a 0 of 0.2679491. I don't know, is that right? Is it not right? Okay.
Yeah, it's 2 minus.
Okay. That was, yep. So next option was going to be, could you hit trace and plug in what was one of our zeros? 2 plus radical 3. Okay, 2 plus radical 3. Is that a 0? Yes, it's showing as an x-intercept. If I hit trace again and go back and do the other one, which I'm being told up here it's already the same, but 2 minus radical 3, is it a 0? Yes. Okay, so you can check those to make sure they are x-intercepts. And again, if you give these answers as decimals, I'm okay with that as well too. 3.73, 0.27, or if those end up, just depends what kind of answers they're looking for. If they want decimals, if they want exact. 2 plus or minus square root of 3 are exact answers. Okay. I don't know if we'll get all the way through example 3, but we've got to get it started. That's the key on this one. If we get it started, we're good. We got more denominators happening here, yes? I get a denominator of x minus 1. Denominator of x minus 3. Take a peek. X squared minus 4x plus 3 happens to factor into x and x minus 1 minus 3. When you go to multiply and get rid of fractions, what's my common denominator? Those two pieces. X minus 1, x minus 3. So what do we multiply both sides by? X minus 1, x minus 3. So work with me real quick. First fraction. X minus 1 will cancel. What remains? The x minus 3 and the 2x. Plus, second fraction, what cancels? X minus 3, x minus 3, what remains? X minus 1, and it's times a 1. On the right side, what cancels? X minus 1 and x minus 3, what remains? 2. From here, you do a bunch of algebra. 2x squared minus 6x plus x minus 1 equals 2. I'm going to tell you, you set it equal to 0. You can either factor using product of AC, or you can check, or you can quadratic formula. Okay, jumping to the end. I solve this. I get answers of 3 and negative 1/2. One of these is extraneous. How can I know instantly? Why do I know 3 is extraneous? 3 minus 3 is 0. without any hardcore checking there, that one does not work. I will tell you, x equals negative 1/2 does work. Okay? You can check that algebraically or graphically. Okay? On your way out the door, or make sure you write down the homework. 2 through 32, 4 through 28 evens. Make sure you get a worksheet from me. I'm going to share with you and one to Vincent. Share with your row. Share with your row. Okay.
Me too. I thought you would be like giving me more to Vincent.
On your desk. You didn't even notice.
They're not in here unless they are. Oh, wait.
We're not.